Hey everyone, Sammy Sade here. Basically, this week I made a Monte Carlo simulation project to estimate the value of pi. And so I'll be walking through how it works here, and so let's just begin right here. So first off, I kind of have to explain what the Monte Carlo method is, and essentially the method is that it's a type of technique that is used to solving problems based purely on random samplings in very simple terms. So first off, you need to first set up the environment. Currently, I'm in a virtual environment for this because we'll be using some Python libraries, including random and matplot, which are the main two libraries I've used for the simulation. So if you're trying to work along on this one, you need to have those two installed first. Uh, Now, basically, here's the gist of the idea. We create a square within a circle inscribed in it. By randomly placing the points inside the square, we can make a approximate ratio between the points inside the circle and the total points, which can give us the estimate of pi. Now, let's just take a quick look of the code here. And first off, we set up some parameters such as points inside the circle, the radius, and all that. Number of points. So the more points that you add on to it, the more accurate it will be. For the sake of this simulation, we added 1,000 points. So we'll just be looking through this and that. Um, I've written up a loop to generate the random coordinates x and y between -1 and 1. Between the intervals of those. Points lies within the circle. We can count it as inside the circle, and we count it as an inside point. Um, After all the points are generated, we calculate pi as 4 times the inside points divided by the total points. The more points we add, obviously, the more closer that is to the approximation of the actual value of pi. And as you can see here, and lastly, we just say the estimate, and then here we're just going to be visualizing the results. I think it's easier to look in that way. um and that's like pretty much it for this project. So all we have to do now is to just run it. So now we got a result. Basically the estimate of the pi is 3.196, which is pretty close to 3.14. So it basically means that our simulation is pretty accurate, and that's pretty much it for the simulation here. Check out the encoded installments on the website, and also check out the post for this for the picture of the result.